Okay, so we've been through the entire chapter, and we're getting close to coming into Testville. So I thought I would do some questions that are likely going to be on the exam that you're going to take, or similar to it. Remember where we started. One of the questions in the book is 9 pi fifths radians equals how many degrees? Well, so this is pretty formulaic. When we're going from radians to degrees, we're going to multiply by 180 degrees over pi radians. And you'll notice I'm not writing radians in the bottom. I'm just assuming that this is obvious. So 9 pi fifths radians times 180 over pi degrees. This cancels out. We have 9 times 180 over 5. There's the degrees. If you or anybody who's reasonably smart can solve this without a calculator, but I'm lazy today anyway. So, and I have one of these, so you might as well use it. 9 by 5. This is 324 degrees. Okay, pretty straightforward. Do you have to know how to do this? Absolutely, absolutely. Similarly, suppose we want to go from 36 degrees to radians. Well, we know that going from degrees to radians, we have to pass through we're going to want radians on the top and degrees on the bottom, so the degrees cancel out. So 36 degrees times pi over 180 degrees is, the degrees cancel out. This is 36 over 180 times pi. And often it is the case that we leave pi in there, even though pi is 3.14 and some change. Let me see. So 36 divided by 180 is 0.2. So this is equal to 0.2 pi. It would be more typical to write this. 0.2 is 2/10. This is pi over 5. One of the things that might be confusing is that times pi. You might see this written sometimes in your book as 0.628318 change. That's what this is equal to. 36 degrees is equal to 0.62 and some change radians. We tend to leave the pi in when we can, though. A lot of times this is just arbitrary. Sometimes the arbitrary habits of mathematicians and math books change a little bit. It drives students crazy. I'll give you a really good example of this. I actually saw a full-fledged argument at a major university, a Tier 1 university in graduate school, about this, the natural log of x and log x. Of course, everybody's been through algebra. You know that this stands for log base e of x. In America, this stands for log base 10 of x. However, in England, in particular Roger Penrose's work, which my friends have been reading, these are the same. So a lot of times you just got to know what the notation is and where you are and who you're talking to. And sometimes it can be very arbitrary. So just pay attention and don't get freaked out if something doesn't look right. Just check it out. Ask a question. Let's see. Another question. Simplify. Ooh, and there's the world's ugliest y. What do we got? Tangent t plus pi divided by sine t plus 2 pi. Well, okay, so there are formulaic ways that you could use to do this, which we're going to be learning starting in the next lecture series. However, this is simple. You're supposed to know that tangent has period pi, so this is the same as just tangent t on top. And sine has period 2 pi, so this is sine t on the bottom. So this is sine t over cosine t. This is tangent right here. So this bit is equal to this, divided by sine t. Now, sometimes people get freaked out by this. It's like a fraction rolled in a fraction. However, sine t is really sine t divided by 1. Division by a fraction is the same as multiplication by the reciprocal. So this top bit, sine t over cosine t, divided by sine t over 1 is really the same as 1 over sine t. And yay, we have some cancellation. This is 1 over cosine t, but on your test you would be writing secant t. Pretty straightforward. Hopefully you've been doing all your homework problems and reading the book. You're speaking a new language, you just kind of got to get used to it. Let's pick another choice problem. No, I just picked this one at random. Sine pi over 6 plus 1 squared. Sine pi over 6 plus 1 squared equals. Well, you could use a calculator for this. Yeah, actually, you'd kind of be stupid not to use a calculator for this. Although it'd be good if you knew that sine of pi over 6. Pi over 6 is 30 degrees. Sine of 30 degrees is 1/2. This is 1/2 plus 1 squared. This is 3 over 2 squared. This is just 9/4. This was a dumb question, especially in the advent of calculators. Trying to find some interesting problems here that you can expect to see on your exam. Okay, suppose that I tell you that the cosine of some angle alpha is equal to 1 over 1 minus x. What are the other trigonometric identities associated with this? How are you even going to do this problem? And this is why I want you to be able to think of this right triangle, like this box, triangle, and circle. And here's alpha. I'm taking away the x's and the y's and the stuff because sometimes we're going to do things differently. Cosine is just, so the cosine of alpha is circle divided by box. I realize this is very abstract and obscure, but it's whatever it is. That means that this, so this is circle, this is box. And what you need to do is you need to construct a triangle that looks right. So it must be that this bottom part is 1, which would typically be on the x-axis, but it doesn't have to be, it's floating free. And this is 1 minus x. What is this? This must be this squared minus this squared. Actually, I'll do this over here because it's going to be a bit messy. Remember, a right triangle, here's x, here's y, here's r. R equals x squared plus y squared. These x's and y's, I don't want you to think of having to do with anything with this x. And this is why I'm using different symbols here. Actually, we're just going to figure out what sine alpha is for this because I'm almost out of time. So it must be the case that this is equal to this squared minus this squared. 1 minus x squared minus 1 squared square root. 1 minus x squared by formula is 1 minus 2x plus x squared. Then it's going to be minus 1 square root. This is going to be the square root of x squared minus 2x. I just fixed some things around in my head. Let me make sure that's right. That squared and that squared, that's positive. Minus 2, that's right. Subtracting that. Okay, so that means that the sine of this angle, which I already have written up, is equal to this divided by this, which is the square root of x squared minus 2x divided by, 1 minus x. This is really important to be able to construct these kinds of things because when you get to calculus, this is really how you're going to be using this. And it is time to go. I'll see you tomorrow.